Hi children, this is Lakshmi Arvinda. Today we are going to discuss about the algebraic expressions, which is our chapter number 2. Before going into the chapter, first we will see some points which we have to remember. First one is a constant. Constant is a symbol which has a fixed value. All the real numbers will come under this constant. For example, 5. 5 is a value, whatever the situation, whatever the sum you will take, the value of 5 will be a 5 only. Now come for the variable. A variable is a symbol which does not have any fixed value. The value will change according to the situation and according to the requirement. All the alphabets will come under these variables. Means A, B, C, D, X, P, K. All alphabets will come under these variables. Next one is a term. It is a number or a variable or a combination of number and variable. Here we can see the example 9, 3x, 4.4by and so on. Next one is algebraic expression. Algebraic expression is a single term or a combination of two or more terms using or connected by additive, addition or subtraction, or multiplicative means multiplication or division symbols. Form an algebraic expression. Example 5xy plus 8. Here we can observe two terms. One is 5xy, one more is 8, which is connected by using the addition. Next one, types of algebraic expressions. Based on the number of terms an algebraic expression is having, we'll divide again algebraic expression into different types. The first one is monomial. Here name itself it is showing mono, means a single. A expression which is having a single term, then we'll call it as a monomial expression. Examples 3xy, 3x, 8y, 3x to the power 4 and so on. Next one is binomial expression. Here by is nothing but 2. So now you understand, I think so, a polynomial which contains two terms, then we'll call it as a binomial. Here example we can see that 7 plus x. 7 is one term and x is one more term. Next one is a trinomial. Tri is nothing but a 3, means a algebraic expression which have 3 terms, then we'll call it as a trinomial. Example, if we'll see 3y plus 7x plus 5a, where we can see 3 terms, 3y, 7x and 5a. Next one is a polynomial. Polynomial is an expression which will contain 2 or more terms, and one more important thing is it will contain the variables with no negative integral exponent. Here we have to observe the thing, no negative integral exponent. What is the meaning of that? Means, for example, if we will take x to the power 2. Here x is the base, 2 is the power. Power is nothing but exponent. Here we can observe 2 is the positive. If we will take one more number, x to the power minus 2. In this example, x to the power minus 2, the exponent is negative. So, this such type of negative exponents will not included in this polynomials. Next, factors. Factor is one part of product. Example, if we'll take 8x is one of the product of 8 and x. So, 8 is one of the factor of 8x and x is the one of the factor of 8x. Next one is quotient. A quotient is generalized either a numerical factor or variable factor. If for example, if we'll take 5ab square, here 5 is the factor of 5ab square and 5 is the numerical quotient of ab square. If we will take a is the factor of 5ab square and a is the quotient of variable quotient of 5b square. If we will take similarly one more example, 5ab. 5 is the numerical quotient of ab. Next, children, like and unlike terms. In algebra, the like terms are defined as the terms which contains the same variable and rise it to the same power. For example, here if we'll take like terms 2x plus 19x, where we can observe same variable x and here also x, and we no need to consider numerical quotient. Whatever the numerical quotient, if the variable part is same, then we'll call it as a like terms. One more example, see here the fourth one, 32a square plus 9a square. Here a and a are the same variables, and powers if you'll see here also the power 2, here also power 2. So a square, so we can take it as a like terms. Now if we'll see the next example, 32a square plus 9a cube, here we can see that the variable is same a and a, but one term is raised for the 2 and one term is raised by 3, the power is 3. So in this case we cannot consider this as a like terms, we have to take under the unlike terms. Next one, addition and subtraction of polynomials. Whenever we are doing addition and subtraction of polynomials, like terms and unlike terms will place a main role, because we can add the like terms. If there is unlike terms, we cannot add, we have to leave like that only. Whenever we are doing addition, we are having again two methods. One is horizontal method, one more is column method. Horizontal method means all the terms will write in one row and will group the like terms together. Then based on the quotients, we will add or subtract the terms. In column method, the name itself it is showing, will arrange the terms in a column wise. All the like terms should come in a same column. And again here also same way, by using the quotients, we'll add or we will subtract the terms. Next one, example, here I'll clear that horizontal method in a correct way. If you'll see here, add 6a plus 8b minus 7c, 2b plus c minus 4a and a minus 3b minus 2c. Now in a horizontal method, as I told you already, we will arrange all the expressions in one row, and then we will gather, means we will write together all the like terms, means a terms are one type of terms and b terms and c terms. So all a terms 6a minus 4a plus a, and all b terms 8b plus 2b minus 3b, and all c terms minus 7c plus c minus 2c. Now if we will come for the a terms, 6a minus 4a we will get 2a, 2a plus a we will get 3a. Then b terms 8b plus 2b minus 3c. Here 8b plus 2b 10b minus 3b will get 7b. Next, minus 7c plus c minus 2c. Minus 7c plus c will get minus 6c. Minus 6c and minus 2c will get minus 8c. Next, column method. Here we'll arrange a like terms in column wise. Here all the a terms in one column and all the b terms in one more column and all the c terms in one more column. Here also the addition and subtraction will take place as we did in a horizontal method. Means based on the numerical quotient and sign, 6a minus 4a we will get 2a plus a 3a, 8b plus 2b minus 3c we will get 7b, minus 7c plus c minus 2c we will get 8c, minus 8c. Next one is subtraction. If we are doing subtraction, here also we can follow two methods. One is horizontal and one more is column method. Now I am going to discuss with you how to do a column method. Whenever we are doing a column method, first here we will follow 4 steps. In a step 1, arrange the terms of the given expression in a same order. Step 2, write the given expression in 2 rows such that the like terms occur one below the other. Keeping the expression to be subtracted in a second row means we have to arrange all the like terms in a single row, and the menu n means the from which expression we are going to subtract, that should be in a first row, and the subtrahend, the which expression we are going to subtract in a second row. Then change the sign of the subtrahend means in a second row expression we have to change the sign. If it is there plus, we will change to minus. If it is there minus, we will change to plus. Then step 4, with new signs of the terms of lower row, add column wise. Now we'll see with the example. Subtract 4a plus 5b minus 3c from 6a minus 3b plus c. So here the menu end is 6a minus 3b plus c. I am writing in a first row, and the 4a plus 5b minus 3c I am writing in a second row. Now I am going to change the signs of the second row. Plus will become minus, plus will become minus, minus will become plus. Now 6a minus 4a we will get 2a, minus 3b minus 5b will get minus 8b, and c plus 3c will get plus 4c. Next, few sums from the exercise I did will go through that children. Question number 1. Separate the constants and variables from the following. Here they given so many terms and expressions. From that we have to separate constants and variables. If we'll see the first one, 12 plus z. Here 12 is a constant and z is a variable. But whenever the z value will change, automatically 12 plus z value also will change. So it will come under the variable. Next one is 15. Here 15 is the constant. Whatever the situation, 15 will be 15 only. So it will come under the constant. Next one, minus x by 5. Here x is a variable, 5 is a constant. But whenever the value of x will change, then x by 5 value also will change. So it will come under the variable. In the same way, please go through the remaining terms and try to separate by yourself, children. Next one is question number 2, simplify. Here we are having x terms and y terms and constants. So based on the terms we have to add or subtract. So I am arranging it in a column wise. 7x and here minus 3x, both are like terms. I am writing 1 under 1, and minus 9y plus 5y, again I am writing in one more column, and plus 3 and plus 8 I am writing in one more column. Now in a first column, 7x minus 3x will get 4x, minus 9y plus 5y. So minus is the bigger and the positive is the smaller. Both are having different signs. We'll do the subtraction. 9 minus 5 is 4, and the bigger number is having a minus, so we will get minus 4y. Plus 3 plus 8 is equals to plus 11. Next one, add 5a plus 3b, a minus 2b, and 3a plus 5b. Here also I am following the column method. I am arranging all the a terms in one column and b terms in one column. And here I am going to add 5a plus 3a. All are positive, so no issues. I am just adding and writing 9a. And next column, plus 3b minus 2b. So we'll get 1b. And again plus 5b will get plus 6b. Next, subtract minus 2xy plus 3xy square from 8xy. Here menu end is 8xy, writing in a first row, and minus 2xy plus 3xy square is a subtrahend, writing in a second row. So changing the signs of the subtrahend, minus 2xy will become plus 2xy and plus 3xy square will become minus, and 8xy plus 2xy will get 10xy. For this minus 3xy square, there is nothing in a menu, and so I am writing that directly in a same way, minus 3xy square. Next thing is multiplication. Whenever we will see multiplication, here we are having 3 types. But today in this session, I am going to discuss only about monomial with monomial. Whenever we are doing two terms multiplication, we'll follow three steps. The first one is multiply the signs, second one is multiply the quotients, and third one is multiply the variables. How will multiply the variables means, if you are having the same variable, same base variable, we'll add the powers. This is called as a power law. Now we'll see with the examples. Here if we'll see x to the power 2 into x to the power 4. Here the same base x and x. So I am going to add the powers 2 plus 4. We'll get x to the power 6. Next one is 2a square y cube into 3a cube y to the power 4. Here we are having a numerical quotient. So first I'll multiply numerical quotients. 2 into 3 will get 6, and a variables we are having here 2, a to the power 2, here a to the power 3. So totally a to the power 2 plus 3 will get a to the power 5. Next y to the power 3 and y to the power 4, y to the power 3 plus 4 will get y to the power 7. Next here two more examples. Minus 6y into minus 6y. First here signs also there. So first I'll multiply the sign. Minus into minus will get plus. 6 into 6 and y into y. 6 6 are 36. Y into y. Y to the power 1 plus 1 will get y to the power 2. Totally 36 y to the power 2. Next example. Minus 11 x cube y square into 9x square y. First time I'll multiply the signs. Here minus, there plus. Whenever you are multiplying signs, children, if both are same signs, minus minus or plus plus, you will get a plus. If both are different signs, you will get a minus. Okay. So here minus into plus will get minus, and 11 into 9 into x cube into x square into y square into y. So 11 9s are 99, and x cube into x square, x to the power 3 plus 2 will get 5, and y square into y to the power 2 plus 1, 3. Based on that, you please do this exercise sums, and this please send me back. Thank you children. Keep learning. Be safe. Lakshmi Aravinda.